okay? And what we're going to do next, and let's just go ahead here, and I'll stay with that pretty purple color, so we'll just put a check on these boxes we're covering here. Next, we're going to go ahead and talk about earlier parts of Chapter 3. There's actually a wonderful formula here for slope. Now, we have talked about this some as well, and we're going to also talk about parallel versus perpendicular line slopes and look at some of those graphs and so forth and prove to you they really are. So let's take a note here on the formula for slope. And notice rise, again, is the change in y, and the run is the change in x. Now in calculus, those of you ever going to go there, they'll use this symbolism. Delta y over delta x means the change. All right, so let me go ahead and get rid of this real quick. And I'm just going to go ahead and give you a few ordered pairs here. I'm just going to take the ordered pair -2, 7 and 5, 6. All right, now what they're going to ask you is to find the slope of the line that goes through those 2 points. So you have to know this formula, or actually you don't, you'll be provided it, is the slope, or m, equals y2 minus y1 over x2 minus x1. And what I suggest y'all do is go ahead and label each ordered pair. So every ordered pair has an x value and a y value. So the first point we'll call x1, y1. That's where those subscripts come from. Second point would be x2, y2. Okay? And if we had a third point, x3, y3, and so on and so forth, but we won't go there. So now, once you get that, just plug it into the formula and you will find the slope of the line. So y2 minus y1 would be 6 minus 7 over x2 minus x1 would be 5 minus -2. You have to watch your signs here. You don't know how many students make mistakes because of signs, and oh, it's just the beast of math. And you get a -1/7. Okay. Now, we're also going to talk about certain types of lines and their slope. We can just look at a line and tell if it's positive, negative slope, zero slope, or undefined slope, and we're going to look at that next. Now, I can tell y'all right now, any line that looks like this has a positive slope. Now, if you're not sure, you can take a few points on the line and do the rise over run test. Okay, this will always tell you the slope. So if I started at this lower point, I would rise a positive direction. I would run a positive direction. Positive divided by positive equals positive, and that would give me my slope. And you would certainly want an investment like that, wouldn't you? If you were going to invest, you would want your line to look like that. Here is the line you would not want to look like here. And I forgot my line tool. See what happens when I forget my line tool? That's what you get if you don't have a ruler or your line tool there. It just looks ugly, doesn't it? But I can tell you, you do not want this investment. This would be a negative slope. And if you weren't sure, you could take a few points here again. Any 2 points on the line. It doesn't matter which one you start at. You could say, well, the rise would be negative, the run would be positive, and the rise over run test, negative divided by positive is negative. You lose money on that investment. So you'll be able just to look at lines and know if their slope is positive, negative, or whatever here. All right, we've got 2 other ones to consider. We've got a line that goes like this. That one doesn't even look great with my line tool, does it? It's a little bit yucky here. And this one confused my lecture classes a little bit. The line that goes like this. Now, I always told my lecture classes, for you nursing students out there, you never want to be on a heart monitor and have this slope, because this is a slope of 0, and any vertical line has what's called an undefined slope. Now, again, if you're not sure, just take a few points here, and we'll just put a few points on both of these lines, and we'll try to make them equidistant here. So we'll call this distance we put on both lines 5. All right, so on this one, if we did the old rise over run test for slope, which is its definition, this one we would rise 0, run 5, so any fraction with 0 in the numerator reduces to 0. And if you're building buildings or architecture or things like that, you want a 0 slope when you're making your floors and things like that. I mean, you don't want to incline up and down in your living room or anything. That'd be kind of crazy. Whereas this other line here, if we did the acid test of rise over run, it would be 5 divided by 0. We would rise 5, but we wouldn't run any. And whenever you have 0 in the denominator of a fraction, undefined. So now you can look at any line and you can tell me slope positive, negative, 0, or undefined. You can take 2 points and calculate the slope. So we are just making great progress here. And we will now continue the discussion. Let me go back to the handout here one more time. And this next point I'm going to make is huge. So I'm just going to go back and forth here. It takes a second. Bear with me. And here we go again. All right, so now we have done examples tonight, and I'm only halfway through the chat, so this is great this evening. Covered graphing in standard form, covered graphing in slope-intercept form. We have covered the slope formula, so we are getting down to 2 boxes left. And what we're going to talk about next is parallel versus perpendicular lines. Now I'm going to abbreviate parallel with that little abbreviation here, okay? Parallel lines, notice the definition, all parallel lines have the same slope. Perpendicular lines, which is abbreviated this way from your old high school geometry classes, form right angles. So sometimes they put a little box in there, and notice that perpendicular line slopes are negative reciprocals, all right? So when we're doing this, this is what we're going to talk about next. Let me just give you some examples here. And let's say if I wanted to start out giving you a slope of negative 2/7. Okay, hopefully you would look at me and go, Young, well that line I know is going to go this direction somehow because it's negative. All right. Also, if I said, well, what would be the slope of the parallel line to that? Remembering parallel lines have the same slope, you would say, well, that would also have a slope of negative 2/7. And what would happen is you may have a line like this that just goes through y at a different point, but the rise and the run would be the same, if you can see that. So I'll just kind of sneak that in here. So that's why parallel lines have the same slope. Now, if they ask you the slope, oops, let me grab my tool here. The slope of the perpendicular line, that is the negative reciprocal of 2/7. So you would have to not just change the sign on whatever slope it was, but also flip the fraction there. So the slope of the perpendicular would be 7/2. And to make a perpendicular line here out of that, you can see that once we do that, and I'll try to see if I can make a pretty one here, that this would form those nice right angles when that happened. And if I did it on a piece of graph paper or you do it, you would actually see that very well. All right, so let me clear this off real quick. Let's do one more to make sure we got it. If I gave you a slope of positive 8, okay, what would the slope of the parallel line be? Okay, well, it would be positive 8 as well. The slope of the perpendicular line, negative, what is the negative reciprocal of positive 8? Well, you'd have to change the sign and then take the reciprocal of that. Now, I know you're saying, Young, that seems pretty easy. What is the catch? All right, well, here comes the catch. Let me clear this off here. They're going to give you two equations here. Y equals negative 1/4 x plus 5. And let's take another one here. 2x minus 2x minus I'll say, let's make it 2x plus 8y equals negative 3. So what I did here is I gave you an equation in slope-intercept form, and I gave you an equation in standard form, or general form, depending on how you want to say it. And then I'm going to ask a question here, pose a question. Are the lines above parallel? And I put an extra thing in there. Perpendicular or neither? Right, now, the only way you can answer this question is to find the slopes of the two lines. All right, now you can look at the first line, hopefully, and say, well, gee, that's in that nice slope-intercept form. This is the y equals mx plus b form, and the slope is right here, is negative 1/4. Okay? I'm going to get rid of that little typo there. It's bothering me. Okay, it's gone. I'm such a stickler for details. Now, the second equation, Young, what's the slope? What's the slope? We can't tell the slope from this general form. We'd have to do a few things. I'm going to put that can't tell slope. I'm going to go put a frowny face. All right, so what we're going to do is solve for y to get the slope. So we're going to take the 2x and subtract it from both sides. So we're going to get the second line in that slope-intercept form, and we'll say 8y equals negative 2x minus 3. Divide both sides by 8, and y will equal negative 1/4 x minus 3/8. Now we can see the true nature of this beast. We can say, hey, wait a minute. That second slope is also negative 1/4. So by definition, if the slopes of those lines are the same, we can say they are definitely parallel. Now, had the other slope, let's say we solved for y on that right side, we would have got positive 4 for the slope, then it would have been perpendicular. It would have been negative reciprocals, and sometimes it's just neither.